Okay guys, what I need you to do is continue vocab entry number 3. This is not a new vocab entry. We are going to continue with the, right after the last thing that you wrote for the States of Matter flipped video. I'm breaking out some lab work documents that you're going to need to create prior to us doing the lab on Wednesday. So when you come to class on Wednesday, this should already be done in your vocab notebook, okay? So this is our vocab 3 lab work. The purpose of the lab that we're going to do is determine approximate melting points, boiling points, and freezing points of substances. I need you to write down this statement. Everything you see in red right now, I need you to write it down. All right, so we'll have the purpose of the lab written in our notebook. All right, materials. I'll provide you a laptop here at school. You need to have your vocab notebook, and most certainly, bring your brain. Again, everything that you see in red needs to be written down as part of our lab work, okay? So the first thing you're going to do is when I tell you where to access the lab, you're going to click on the video button, and it's going to show you a video about melting points, boiling points, freezing points of substances. Should not be new material to you, we've already discussed it. Then you're going to select water. We're testing 3 substances, one of them is water. Let's start with water because we already know the melting, freezing, and boiling points of water. What you'll do is in your vocab notebook, and there will be a chart that you'll sort of keep your data for water, and then you'll keep your data for mercury and your data for iron. But you'll make a prediction for water about what will happen when we add heat to a container of water. Shouldn't be that hard. You already know when we add heat what happens to the molecules, but I need you to make a prediction anyway. Then you'll click the heat button on the lab and observe what happens to the molecules. And you're observing it in 3 ways. The state of matter, the molecular activity, what happens to the molecules as we add heat, and then what happens to the temperature. Then what you'll do is you'll click the graph button to see the temperature versus time. What happened to the temperature over that period of time when heat was added. All right? And you'll add these points to the graph that you create as part of this vocab entry number 3 continued. Once you've seen the graph, you'll click heat again, make more observations, and then what you'll do is, again, we're looking at states of matter, molecular activity, and temperature. You'll click the graph again, update the points on your graph, okay? You'll repeat these 2 steps again to get a 3rd piece of data for when we add heat. Making observations, and then updating the graph. Okay? Once you've done that, we're still talking about water. We have not switched substances. You're going to click the cool button and make observations about what state of matter it is, molecular activity, temperature, and then you'll click the graph button again and graph the results. Now, those steps that I just mentioned to you, you will do all of that for water, and then you will graph the results of water. And then you'll repeat those steps, switching substances to mercury, graphing and making observations, and then switching it to iron last. So you have to draw a graph in your vocab notebook, and you may want to turn your vocab notebook sideways so the spirals are at the top and take up as much space as you can. Okay? On one side of the graph you have temperature. On the bottom of the graph this says time. Okay? In the middle of your graph over here for temperature will be 0 degrees. It needs to go up to 100 degrees, and this is temperature in degrees Celsius. It also needs to go down to at least minus 70. It would be best if you could get it to go down to minus 100. Okay? And then you'll draw this dashed line to show where the 0 line is. Every time you stop, after you click the heat button and you click the graph, you graph where the line is for water at that particular time with that much heat added. So you'll have these different points, and then when you get all of your points after you've heated it and then cooled it, you will then go ahead and graph the results for heat and connect the dots. Notice up here I have a key. You can pick any color you want to represent water, any color for mercury, any color for iron. In a really good graph, these points would be connected with a ruler. Finally, you'll need to create a data table. All right, very simple data table, and it is in 4 columns. All right, one column is the substance, one column is the melting point, one column is the boiling point, and one column is the freezing point. And then you can see the 3 different substances we are testing: water, mercury, and iron. The purpose of the lab is to try to approximate what the melting point, boiling point, and freezing point are for each of these 3 substances. That's your final goal. In addition, I will be printing out for you questions, post-lab questions that you'll answer as you go through and do this lab work, okay? So it's very, very important that when you come to class on Wednesday, the instructions are already in your lab notebook. Your graph is already drawn. Don't put any points on it yet because you don't know exactly what I need you to do for that, and we're collecting data in class. And then you need to have this data table collected as well. Again, as you go through the lab, you'll have a section dedicated to water where you're making your prediction, your observations, and then you're plotting your points on the graph. And then you'll have a section for mercury where you're writing your prediction. You are making observations as you go through and then plotting on the graph as well. Once you have the graph data and your observations, lastly, you will fill in this chart with where you think the boiling point, freezing point, and melting point of water is.